Okay, let's jump right into this explainer. Look, if you are managing modern enterprise data, you're probably facing a massive dilemma right now. How do you actually harness the incredible power of AI to analyze data when that data is highly confidential? Well, to figure that out, we're looking at Vectra. This is a platform specifically built to bring AI to sensitive data analysis. Our goal today is to map out exactly how an organization can safely turn natural language requests into sandboxed Python code using a locally hosted LLM. And the best part? Keeping that confidential data strictly within your own walls. To do that, we've got a packed roadmap. We will start with the sensitive data dilemma, move into the governed system architecture, and then break down the 6-stage job pipeline. After that, we'll dive into safety gates, self-healing, tracks and roles, and wrap it all up with a summary. Let's get to it. Right, Section 1. The sensitive data dilemma, public chatbots versus secure workflows. We all know the productivity gains AI offers, right? But if you're an analyst, you're often trapped by strict security constraints. Think about the danger of using a standard public chatbot. Throwing your company's spreadsheets into an ungoverned AI is a massive data leakage risk. You have zero audit trail, no residency guarantees, and literally no control over how that model uses your proprietary data. But on the flip side, governed AI analysis provides a completely on-premise, secure, and auditable workspace. It totally removes the risks of public clouds because your data never actually leaves your infrastructure. So, the dream is basically this: blending the sheer speed of AI with the total control of a closed system. It is like having the flexibility of Excel, the raw power of Python, and a dedicated AI analyst all rolled into one. But the absolute keyword here is governed. It finally brings an end to those painful hours of manual spreadsheet wrangling, replacing those tedious tasks with repeatable AI-generated Python code, all with zero data leaving your server. Moving on to Section 2, governed system architecture and keeping data on-premise. So how does the platform actually pull this off? Well, it is all about stringing modular components together behind a strict on-premise boundary. You access it through a browser UI, which routes through a reverse proxy and an API service. But the real heavy lifting, that happens with the local LLM, in this case Llama, and a dedicated code sandbox. There's even an optional remote agent for handling files on separate hosts. Ultimately, the architecture itself acts as your security moat, keeping computation entirely in-house. Section 3. The 6-stage job pipeline, replacing manual tasks. Let's look at this from the analyst's point of view. When you trigger a job, the AI doesn't just blindly guess and execute. It flows through 6 very distinct automated phases. First, there's pre-flight validation, followed by the LLM generating a Python plan. Then, a crucial safety gate checks that code. If it passes, we move to sandboxed execution. Finally, the system handles output registration for your generated files, and the LLM writes up a natural language summary. It is a seamless way to replace manual manipulation with repeatable code. Let's zoom in on that very first step for a second. Pre-flight validation is basically your intelligent gatekeeper. Before a single line of Python is even generated, the system validates the files and estimates resource usage. It actively warns you about potential token limit breaches or excessive runtimes before you commit any expensive GPU resources to the task. Section 4. Safety gates and self-healing, enforcing strict boundaries. Because let's be honest, letting an AI write and run code on your internal network introduces some huge risks. That is exactly why this static safety gate is your absolute failsafe. Before the AI's code gets anywhere near the sandbox, the system parses it into an abstract syntax tree, or AST, and runs a strict block list check. It acts as a rigid, impenetrable wall between the LLM's imagination and your server's reality. If it spots anything dangerous, execution is completely blocked. To get really specific here, the system explicitly blocks dangerous network imports, things like requests, urlib, or socket. It also blocks dynamic execution calls like exec and eval. This means that even if the AI somehow goes rogue and hallucinates a malicious script, it literally cannot reach out to the internet or run rogue commands. The sandbox stays totally secure. But hang on, what if the code passes the safety gate? It is perfectly safe, but it just crashes? Maybe there's a logic error, or the AI was looking for a column named revenue, but the spreadsheet actually says sales. Well, this brings us to a truly brilliant feature, self-healing logic. When a safe script crashes, the orchestrator instantly captures the error output and the original code and feeds them right back to the LLM. The LLM then reads its own error logs and actually corrects the script. It will run up to 2 of these automatic retry and fix cycles, fixing itself without you ever having to intervene. Section 5. Tracks, Roles, and Collaboration. Standardizing the analyst workflow. So we know how a single job runs, but how does this scale for an entire team? Instead of starting from scratch with a blank prompt every single time, you attach what are called tracks to your projects. Think of a track as a reusable analysis strategy. It has your predefined prompts, your resource limits, and your validation rules all baked in. This is exactly how you translate complex tasks into repeatable code and guarantee consistency across different teams. And on the security side of collaboration, role-based access control, or RBAC, keeps everything incredibly clean. It strictly separates who can just view the shared data from who can actually upload files or trigger AI jobs. It's a very straightforward hierarchy from viewer all the way up to owner, which makes managing team projects a breeze. There's also this really clever security detail on top of that access control. The system completely hides the existence of a project from unauthorized users. If you aren't on the approved list, you don't get a forbidden message. You just get a 404 not found error. This stops information leakage dead in its tracks by refusing to even confirm the project exists to an outsider. All right, Section 6, Summary of Governed AI and the Future of Secure Analysis. Let's pull all these threads together. We've seen how a governed workspace systematically replaces those totally tedious manual spreadsheet tasks with repeatable Python code, all while protecting your highly sensitive corporate data through a strict on-premise boundary. We walked through the 6-stage pipeline, saw how AST safety gates stop rogue execution, how self-healing logic keeps things reliable, and how access controls secure team collaboration. Which leaves us with a pretty fascinating question to ponder. Knowing you can now combine the incredible generative power of AI with airtight on-premise governance, how will strictly governed on-premise AI redefine your team's approach to analyzing confidential data? It's no longer a choice between productivity and security. With governed AI, you finally get both. Thank you so much for joining me for this explainer.